Hello, my name is Peter Childs and welcome to this Institution of Mechanical Engineers session on Enterprise by Design. I have an agenda. Everybody always has an agenda. And today I'm going to give you some context for this presentation. I'm going to talk about creativity and then look at the subject of commerce. You're going to see the trend here, lots of C's coming up. Then we're going to go back to creativity and look at creativity tools, both from a 20th century perspective and right up to date. Then we're going to look at the subject of change and conclude the presentation. So just a bit of context and to introduce myself. So I'm a professor at Imperial College London, and I was the founding head of school for the new Dyson School of Design Engineering, which got set up about 6 years ago and is now operating at scale. I have a few other titles. I'm Professor at Large for the Innovation Design Engineering double masters run jointly between the Royal College of Art and Imperial College London. And I'm also a Professor of Excellence at MDH University in Berlin. And I've had the delight and the privilege of helping advise and input to about 100 spin-outs over the last 12 years. And in terms of some of my own current practice and a desire to practice what I preach, I do lots of teaching and lots of engagement in advising companies. I'm also engaged with a few companies directly myself, such as Cubot Limited, Strategy Foresight, Narrative Shop and Discreco. Over the years, I've engaged as an academic in a lot of funded projects and have had lots of great collaborations over the years. And I've also done the academic thing, engaging in writing papers, about 20 books, and over the years had the privilege of engaging in a lot of design work. And you can see some of my designs on the right-hand side, ranging from engine components, axial turbines, centrifugal compressors, through to alpaca knitwear. I ran a knitwear business for 6 years, and ventilators for premature babies, to name but a few. Mentioned that I'm a professor at Imperial and helped set up the new Dyson School of Design Engineering over the last 6 years. And we produce the innovators, change makers, and new knowledge of tomorrow. And we do this through leading edge research and practice in the subject of the domain of design engineering, which we see as the fusion of design thinking and practice within a culture of innovation and enterprise. Within the school, we run 3 degrees. One of them is called Innovation Design Engineering. And although the school is new, this particular program was formed 40 odd years ago. We're celebrating our 40th anniversary at the moment. And when we formed the school, we pulled this degree into the new school and we became the Imperial home for the Imperial part of the Innovation Design Engineering program. This degree is focused on student-generated projects, and we form innovators. And we do this through precision analysis, through a focus upon people, where people are relevant. Not all designs are for people. If you're designing a software system, perhaps your principal stakeholder is actually integration with another software system. So we extend our consideration to designing for the relevant stakeholder. We have a particular focus on prototyping, be that physical prototyping or non-physical prototyping. We're all familiar, for example, with wireframing or acting out through things, a scenario through a skit, perhaps. And in everything that we do, we attempt to be progressive with purpose. So this is Innovation Design Engineering, a double masters run jointly by Imperial College London and the Royal College of Art. And on the right-hand side, you can see some of the output associated with our alumni over the years. People like Alex Kaligroulis, 3 of the original engineers for the Dyson team, 7 key innovators at Philips, and design director at Nokia during its glory years. We also run a degree in design engineering. This is an undergraduate program, and we're new, just had our first cohort of graduates, and we have a cyber-physical curriculum, lots of modules on computing, electronics, robotics, gadgets and gizmos and mechanisms to develop and upskill our students. It's a design engineering degree, so no surprise that sketching and computer-aided design and pitching will be part of our curriculum. A particular focus on computational aided engineering in order to aid students in going from a sketch through to a solid model, through to modeling and analysis. Lots of prototyping, as mentioned, both physical and non-physical prototyping. And we take the students through their learning and embedding of their learning through integrated design engineering projects. So that's a bit of context. I'd now like to talk about this huge subject, creativity. We're all creative. Let's see where this goes. So ideas. So a rhetorical question. When do you get ideas? Hopefully a few responses has come. When do you get ideas? How do you get ideas? Where do you get ideas? Let's expand it a little bit. Well, I don't know what came into your head this particular moment, but perhaps some of you said whilst you were sleeping or in bed. Perhaps for some of you it was in the shower or the bath. Just how many feet are there? For some of you, it might have been when you're driving, when you're traveling, when you're on the bus, on the train. Could have been during boring lectures or boring meetings. Hopefully this isn't going to be a boring lecture, but hopefully you will get lots of ideas too. Well, these are known as the B's of creativity, and we find that when we look in depth at creative moments, they tend to be associated with the bed, sleeping, in the bath or showering, on the beach, on the bus or travelling, in the bar, in boring meetings and lectures, even on the bog. And the common characteristic of those B's of creativity is that we are relaxed. Concentration's great for getting things done when you know what you're doing, but for coming up with ideas, the bulk of research indicates that we're more productive in terms of coming up with ideas when we are relaxed. And there's good psychological and neurophysical reasons for that. I'd now like to just move on a little bit to the embodiment of ideas. And you may be familiar with the traditional inventor approach. This is where you come up with a bright idea, maybe do some sketches and calculations, and then take it forward through some embodiment of your idea, some detailing, and look at what you've got. And if you like it, great. But if you see some fault or flaw, maybe you'll go back and do some more sketches and calculations, further develop the idea, and go around that iterative loop a number of times until you've got your final solution. This inventor approach to creativity or idea realization has been around for a long, long time. And I had the delight recently of chatting to Neil Barron, CEO of Lightlock, and you'll see some of his work and sketches on the right-hand side, and then the embodiment of the Lightlock product, which is an amazing product for trying to improve the security of our bicycles. Check it out if you haven't had a chance to already. That's the Inventor approach. But we can be more sophisticated in our management of design process. And on the right-hand side, you can see a development of the classic total design model, originally developed by Stuart Pugh in the 1980s, but here updated in 2018. And this is taking a much more systematic approach to design. And a whole range of systematic processes for design have been developed, both in academia and in industry, and many companies and OEMs have their own systematic design process, which they implement within their project management processes. So we've talked a little bit about context, my personal context, and we've taken a brief look at creativity. I'd now like to move on to the subject of commerce. And this is a presentation looking at enterprise by design. And I picked up upon a number of the enterprises that I've had the privilege of seeing come into being through my roles at the Royal College of Art and Imperial and other universities and in the workplace. So let me introduce Bear Conductive to you. You can see part of the team on the right-hand side there. And what they came up with was a chemical paint allowing you literally to draw your electronic circuits. And so you could deposit this paint from a tube, this is one of the original products, and connect up an LED to switches or engage with your own circuit boards and do plug and play electronics. And they've been amazingly successful as a team, bringing out product after product. And now their business is morphing into a smart surfaces business. You'll see lots of QR codes if you want to follow the link and check out companies like Bear Conductive. This is Bladebug, highly innovative company developing robot solutions for enabling wind turbine blade inspection. We know the current solution. You stop the wind turbine, you take a team out, climb up the tower, abseil down the blade with it in its static condition. And that's a solution. It's a pragmatic solution. Is it a safe solution? Well, the Bladebug technologies enable deployment of the robot, perhaps out of a hatch on the tower. Stop your turbine. Bladebug moves across the blade, able to inspect, able to undertake some interventions for blade maintenance. The wind power farm that we're showing in the top figure is the Rampion farm, sort of 400 megawatt farm. Impressive engineering. Gravity Sketch is a relatively recent spin-out, and they have developed an amazing augmented reality 3D design platform, and it enables you to create using VR, using the handset, exploring your design. And I'll just play a little video which gives you a little bit of an introduction to Gravity Sketch. You get the idea. Gravity Sketch, amazing augmented reality, contemporary approach to computational aided design. So Cicadia have developed an innovative approach to patient or client monitoring, and their innovation has taken off through this period of lockdown and international crisis. Their technology, which was long in the development, but just is right for this time, monitors a patient's respiratory rate and sends notifications when your respiratory rate deviates in some way from normal practice or your normal status. And they've been very successful in getting medical compliance regulations, regulatory approval, and this device is just of its time. I've got a version on my desk actually, and maybe during Q&A we'll pull it out and take a look. The safety net innovation tackles bycatch. We've probably all seen this issue associated with fishing. You're going for a particular fish type, pull up your nets, and you've caught some items which you're not necessarily got the market for, and they just end up being thrown away. So the safety technologies uses light-emitting devices in order to help the trawlers catch the target specimens. And they've been trialing this, and as a result of the successful trials, they've now been pushing forward with a product for market release. Plumis is another technology that's emerged out of the innovation design engineering double masters platform. This involves a device to enable a mist to be emitted from a tap or faucet, and it's an alternative to the traditional sprinkler systems. By emitting mist, fine mist or spray, as the small droplets evaporate, it will displace oxygen, thereby suppressing the fire event or the heat event. And the team have employed machine learning associated with continuous monitoring. So again, another example of a bright idea being taken forward through advanced technology and then implementation. And this has been recognised, the Plumis technologies have been recognised with multiple awards around the world. And one of the big awards in the design world is the Red Dot Award. And the Plumis team rightfully won Best of the Best. Some of the innovations I've shown you are very physical in format. But not all product services and systems involve a physical product. The Farewell innovation enables users to write a will online and also execute probate online as well. And they've been going for a number of years, and they've grown very quickly over the last 2 or 3 years. And of course, the ability to apply for probate from home and even taking care of cremation remotely has potential benefits. We can see that through the current era. Now I'd like to introduce Cubot, hopefully something that absolutely resonates with this audience. This company insulates cold and drafty floors, and it's developed a whole series of robotic technologies so that you can open a hatch for your floor voids, send the robot in. The robot is able to survey and then spray thermal insulation foam on the underside of wooden floorboards or suspended concrete floorboards, wherever you've got a void that needs insulating. And this technology has now been in operation for about 8 years, and the company's operating at scale.
My name's Dana Cavell, and I'm the robot manager here at Cubot. Here at Cubot, we build robots for the construction industry. This here is Annie. Annie and her other robotic friends are used to apply underfloor insulation to suspended timber floors. A team of installers will arrive at your property, they will get out the spray equipment, they will then make an access hatch within the property, they will attach the spray equipment to Annie, insert her into the void, she will then survey the area, and then we will go through and perform the insulation. We then measure the depth and thickness of the insulation to ensure job well done. A lot of energy is wasted within the UK by heating old, poorly insulated properties. If we insulate the 8 million properties within the UK with suspended timber floors, it's the equivalent CO2 savings of shutting off 2 power stations. At the moment, Cubot is working with local authorities and housing associations, but the plan for the future is to deliver this service to everyone across the UK. And then the world. Is that too creepy? That's not going to be it, is it?
Thank you very much, Dana, our amazing electrical engineer and robot manager. The company's gone on to, as well as developing the robotics technologies, we've got surveying technologies and quality assurance tools. And I had the privilege of being one of the original founders for this company and its first ever chair. Just stepped down, got an amazing new chair, able to take the company forward at scale and help us insulate hopefully hundreds of thousands of properties here in the UK and abroad. To boot, we've just won the Queen's Award for Enterprise 2020, so we'll be flying the flag accordingly for the next 5 years. So I wanted to introduce these examples of commerce really as examples of what I would call enterprise by design. There is a common characteristic to all of these companies, and there's been this whole succession of them. It's about the application of, or taking advantage of bright ideas, your creativity, but embodying the ideas through expertise. Then, not stopping there, prototyping and using prototyping to help you develop your design and your engineering. Embracing an innovation culture in order to inform the quality of your business ideas, the quality of your engineering and design. And then taking that forward to implementation in the marketplace. And this is where translation and scaling are so important. In the UK, we've had some great examples of scaling over the centuries, and it's a practice that is now being understood more and more. And I can envisage so much more scaling of our enterprises to operating at significant size, both here in the UK and abroad. So, giving you a few examples from the world of commerce, I'd now like to go back to the subject of creativity and in particular look at creativity tools. You may be familiar with a whole host of really good creativity tools, all sorts of types of brainstorming, from traditional sticky note brainstorming to alphabet brainstorming, grid brainstorming, to name but a few brainstorming approaches. We know a lot about creativity, and there are lots of thinking styles which are helpful to augment and enhance our creativity. There are tools like morphological analysis, which enable you to systematically generate ideas. For the last 70 years, people around the world have been using the principles of invention, and that's been embodied in TRIZ, the theory of inventive problem solving. It's a much simpler approach to TRIZ. We'll take a brief look at it as well. It's called Scamper and easily rememberable, and we'll introduce that in a few moments. There are other creativity approaches such as analogy and metaphor. You may or may not have come across TRIZ, but one of the principles associated with TRIZ, the theory of inventive problem solving, is that there are 40 inventive principles, listed 20 of them here, and here are another 20. The originator behind the theory of inventive problem solving, Genrich Altschuler, he and his team undertook an analysis of the patent database in the Soviet Union at the time, and they noted that the same innovation principles came up time and time again. Well, this analysis has been repeated through the years, and now we have data tools running continuously looking at the patent database, and the same 40 principles of innovation emerge. And Genrich and his team were able to develop a methodology associated with TRIZ to help guide you as to which of these principles to use to tackle a particular problem. Well, you could use that methodology, or sometimes just looking at this list and running through each item in turn and seeing if the principle of cushion in advance, or inversion, or dynamics, or periodic action, or phase change might be useful to you in tackling your problem or opportunity concerns. The TRIZ list of principles of innovation is long, and you can use a different taxonomy. This is Bob Eberle's SCAMPER acronym or mnemonic. It stands for substitute. Can I substitute anything? Can I combine things together? Can I adapt something? Can I magnify, minify, or modify something? Can I put something to another use? Can I eliminate or erase something? Can I reverse or rearrange the items or elements of whatever it is I'm dealing with? So this acronym, very simple to remember, and even if you can't remember what the items stand for, just use one of the search engines and look it up. But each of these words aims to provoke ideas. And so sometimes we've used SCAMPER as poor person's TRIZ. It's a simple way of exploring principles of innovation to tackle an opportunity or issue that you're facing. So I do recommend this little creativity tool to you, little but very powerful. The tools I've just introduced are very 20th century, but they're valuable today. But this is the 21st century. And what you're looking at here is B-Link, a tool driven by machine learning principles. The team behind this data mined a few million papers from the Elsevier database and looking for connections. And in B-Link, lots of different ways you can run it, but you can just put in a single word and explore relations around it. Or you can put in phrases and look at links between them. So you can see this example here, just looking at thermal insulation, related to Cubot after all, and just doing automated brainstorming, if you wish, or mind mapping, and letting the software do the work for you. Again, acknowledging where we are, year 2020, our technology is continuously developing. The images on the right-hand side look very blurry. This is use of EEG technology, 128 sensor net sensors applied to your head, and monitoring the subcranial activity. And again, our application of machine learning to the vast data stream that emerges from these 128 sensors monitoring the electrical signals just underneath your skull's surface. And what we've been able to do by showing a subject or a series of subjects 6,000 images and monitoring their brain signals, we're then able to develop a database which we're then able to apply our machine learning algorithms to, and develop understanding of the underlying signals such that we're able to subsequently explore what a subject is thinking about and visualizing it. So you can see we're not, we don't have image clarity, but some of these images you can pick up on or infer what's going on. And we're getting better and better at it. And so we're hoping soon to move to 128 pixels by 128 pixels, so enhanced clarity. And as our database builds, then the capability of this method will keep on moving forward. Many of you listening to this will have been involved with and own a whole series of patents. And you'll recognize that there's so much rich information in patents. We've got a series of, we've engaged with a series of products. This is the patent inspiration software, commercial software. Simon DeWolf just completed his PhD with us, looking at data mining from patents and seeing whether you can use the information contained within patents in order to identify technology opportunities, technologies which are no longer protected, or and therefore opportunities for innovation, opportunities to combine technologies together, or recognizing that a space is protected and the need to find routes around that. So the patent inspiration set of innovations. We're also looking at now at the images contained within patents, another rich source of information. If you're interested in the subject of creativity, then for the last couple of years, I've been involved with a massive online open course, a MOOC, on creative thinking techniques and tools for success. And here we explore several approaches to creativity. And this year we've had over 100,000 people enrolled on the course. It's available on the edX and the Coursera platforms if you're interested. Okay, drawing towards a conclusion. Let's look at the subject of change. This is not one of my robots. I wish I'd been part of the team. I think they're absolutely amazing. This is the HRP5P humanoid robot developed by AIST in Japan. Fantastic technology. Well, you may have picked up upon my interest in robotics, my interest in construction, and you saw that perhaps through Cubot. Well, let's see the HRP5P robot in action. As I mentioned, amazing technology and impressive engineering. The HR5P robot, fantastic technology, state of the art. I'm going to show you another robot. This is Slider, developed by Petar Kormashev and his team at Dyson School of Design Engineering. This is a bipedal robot with kneeless legs and a vertical hip sliding motion. So a very different architecture. The HRP 5P robot is so amazing. To be able to pick up a 4x8 foot or approximately that sheet of plasterboard, hold it against the wall, and use a nailing gun and do it all effectively is truly impressive. This robot, the slider robot, can't do that, but it has all sorts of innovations. And just check out the simplicity of this robot as we play this video. So that was Slider's early steps. You can see very tentative motion, but the video we're playing is some months old, and it's now able to support its own weight and developing all the time. So advanced technologies. So I wanted to show you those two robotic technologies as relevant examples, particularly to this talk and the audience, of fast change, tackling contemporary issues, whether it's safety in the workplace or potentially last mile deliveries or alternative transportation around environments. These are just examples of change that we're seeing in the technology base. And here you're looking at a table of disruptive technologies developed from Imperial College London and Tech Foresighting team. This is a dashboard of 100 disruptive approaches. Just going to zoom in on a few of them because you probably can't read the table, but it is available online. So just looking in on these, and just like the scamper provocations, each of these is a provocation that we can use to explore. Is there a contemporary approach for disrupting the domain we're in? So, is it going to be quantum safe cryptography? How about cognitive prosthetics, the brain-machine interface or data uploading to the brain, dream recording using technologies such as Pan Wong and the image realization EEG technology that we introduced earlier. So lots of provocations, a very usable chart to help explore additional ideas. But I just wanted to present this as an example of potential change that we might be facing. So let's conclude. I would suggest to you that we do live in a challenging and changing world. What's going to be your response to this? Are you just going to be subject to change, a victim of change? Well, this is an engineering, technology, design audience, so skilled, so capable, captains of industry. And I would suggest that we have another pathway, and that is to be the suppliers of change. Thank you very much indeed for your attention.
Okay. Thank you. Great. Thanks. Thank you for Professor Peter Child's presentation and talk. It's highly inspirational. My name is Jian Dai, Professor of Mechanism and Robotics of King's College London in Department of Engineering, and I'm sitting for a long-standing member of IMechE, MICG, so Mechatronics, Informatics, and Control Group. This is a special annual AGM lecture is today given by Professor Peter Charles of Dyson School of Design Engineering of Imperial College. It's a highly inspirational. I can say this is it's so colorful, particularly in creativity, in all the novelty, all the innovation, and present an innovation culture. I really like this table of techniques, and it's highly noble, highly creative. So if we pick up the one element, DR is dream, reading, and recording. Peter mentioned about how you get your inspiration, how you get your novelty, how you get your thought. It's not from the office, not from the desk, but from your travel, from your bed, from all the B elements. So I thank profoundly on behalf of MICG, Mechatronics, Informatics, and Control Group, thank Professor Peter Charles to give us such a wonderful presentation, wonderful talk. Let's start Q&A now.
Thank you very much, Jan. It's a pleasure to engage with the Institution of Mechanical Engineers. I've been a member and a fellow for many, many years, and it's always a delight to engage with this institution.
Thanks, Peter. That was really wonderful for your talk. I think we are looking forward to reading your book on innovation and creativity. And I think I have a question. Let me go to see. I have a question from Joshua. William Christopher Williams from Rolls-Royce, CAE engineer. And Chris mentioned such a thought-provoking talk. Thank you so much. Thank you, Peter.
That's great. Is there a question?
I have a question from Sanjeev Sharma. Would you classify CK design theory as a meta design thinking, perhaps with trees and other creativity tools, as a means of realizing CK design theory? Peter.
Okay, well, CK theory's been around for a long, long time. Fantastic methodology. And okay, so with creativity, you can be systematic, and CK theory is a means by which you can be systematic, or you can take advantage of serendipity. So yeah, I don't promote one approach to creativity or innovation only. So I'm sure, I mean, this is an engineering audience. Creativity is great, we need it, but on its own, it's not a lot of use. We've got to take ideas forward towards reality if we want to ever have a product or service that we can actually sell. So there are all sorts of systematic approaches, and CK theory is one of them, which you can use to augment your natural creativity. So I recommend to just about anybody that your own capabilities, fantastic, let them out and exploit them. But sometimes it's necessary to add to your toolbox and augment whatever output is coming out naturally. And methods like functional analysis design or some of the systematic approaches using morphological analysis, for example, in a systematic manner for idea generation, or CK theory, can be useful frameworks really to take your ideas to a level of embodiment, adding the details and adding additional ideas. So if it's good for you and you can work with it, or it's good for your organization, absolutely employ it.
Thank you, Peter. Great. And do we have any questions? More questions? You can type in. Okay, we have more questions. We have a question from Andrew Howell. Thoroughly enjoyed the presentation. I found it very thought-provoking and enlightening. Thank you for your time and for all the excellent contributors. And any more message or questions from the floor? You can type your questions. I have a question for Peter. I think you mentioned in your creativity design, it was really novel and really comprehensive. You cover all the area, cover all the thoughts, cover all the way for innovation, for creativity thought. You mentioned about this analogy and metaphor. So how do you apply metaphor in the design?
All right. Great question. I think this, so analogy and metaphor, two of the very powerful and historic approaches in creativity. So a classic example of analogy is, can we look at another domain such as nature and see how nature does things, and then pull that into our context and see if we can get some inspiration from that. And there have been many inventive examples as a result of taking that analogical approach. I think,
thank you.
Just going to add a little bit. I think that both analogy and metaphor are areas where there's a lot of research going on now, where can we actually be more systematic rather than just looking at nature and hoping for inspiration, or trying to use some kind of metaphorical inference. And I suspect that we will see all sorts of data-driven tools coming out over the next months and years, where we can be much more systematic and exploit these principles of invention, creativity, innovation, inspiration in a everyday manner. We can all go through the mental hurdles of analogical reasoning or thinking in terms of metaphors, and then pulling it back from that abstract to your real world challenge. I think the next step for us in the creativity community is to add tools which aid this process.
Thanks, Peter. So metaphor virtually is, can I say, is a bridge which bridges arts and design. That's
yes. So, but you can have you can do metaphor in engineering, and I mean, the great thing about the engineering domain is that it is so massive, so broad, and I'm not sure. Well, the distinctions between the domains have been for convenience. I suspect, and we love to congregate in small clubs, and then we discover this huge, wonderful world out there and take advantage of it. So yeah, I wouldn't just say that metaphor is just for the arts, and you've just called it a bridge between the arts and engineering. But I think metaphors within engineering itself, we could take some pleasure in introducing Ohm's law to people in the humanities, and they would get some value from it.
Thank you. Thanks, Peter. We have a question from Chris Williams of Rolls-Royce. His question about freedom to operate within the IP landscape is very tricky. can the pattern machine learning tools you showed accurately interpret the language of a patent?
Great question, Chris. Thank you for raising that one. So I'm not here to sell. I don't have shares in Patent Inspiration, but it is a commercial package that is out there. I think they've got over 1,000 clients using that software. One of the things it does is it helps you identify what has been patented in the past and what patents have expired. So patents are rich information, both in text and those wonderful drawings in patents. So I know with some of the patent analysis platforms, knowing what's protected now can be useful because that tells you better not infringe that or we'll need to pay license fees or negotiate. But knowing what has been patented in the past and is no longer protected, that is gold dust. So if you're, developing a brand new car platform, so suppose you're doing the hydrogen car of the future, then mining the patent database from the 1990s and previously, expired patents could be very useful to you, because then you could exploit that technology, those ideas, maybe integrate them together to create new IP, new potential patents, and operate in that way. So tools like Patent Inspiration, which is a word-based engine, although it presents its information in fantastic graphics like the heat map I showed you, are great. Developments are now happening on those platforms, so they're now exploiting images as well. So I think there are tools already out there and there are new tools coming.
Thanks, Peter. We have a request for you, I think, from Daniel Wilcock of Imperial College. Thanks, Peter, for the talk. We teach Scamper for our sixth form students, so it was good to see it included. In terms of the B-Link software, is this possible for us to demonstrate to students?
B-Link is available just by, if you didn't catch the link, it is available to anybody. You just register online and students or engineers or anybody can use it. So you just tap in your email and then register and you can use it immediately. So it's on a cloud web service, and so we think we've got the bandwidth for quite a lot of users potentially, and we keep on developing it. But it's useful to you now. Nothing to stop you taking advantage of that. If you didn't catch the link, type in B-Link and Imperial and creativity, and the search engine will probably highlight it.
Thanks, Peter. B-Link is a really powerful, useful. We have another comment on B-Link that's from Yana Rayana up here. From VGI Group Director, his comment is, excellent webinar on creativity in design, very informative tool on creativity such as B-Link. We have a question from Chris Williams of Rolls-Royce. Do the tools suggest areas for further exploration within a patent specialist?
Oh, Chris, you've got a good question here. So the patent online tools that I've been associated with developing or using, it's actually been really clever PhD students that I've just supervised that have done all the hard work and got the commercial projects going. You need to drive them. So it's sort of a bit like Pan Wong's work with the brain-machine interface. It's human in the loop. So the software is not doing everything for you. It's doing lots of data analysis, but you still need to do some direction. to get those hotspots. So in the case of patent inspiration, it identifies hotspots of intensive patent activity. And that might be useful to you in your organization because you can see that there's no hotspot in your area, and therefore it might be worthwhile to really push out several patent ideas or a patent family in an area where there's little activity. But it is human in the loop driven activity at the moment rather than totally automated.
Thanks, Peter. We have a question from Adrian Howell from Saudi Aramco Engineering 1, Process Control and Instrumentation. In your opinion, what's the most significant innovation to have occurred in this century?
Okay, fantastic question. Had you said the 20th century, I would have been delighted to respond. And there are so many great ones from the 20th century, from digital cameras to I sent my first mail, which we now call email, in the 1980s. So it's easy looking back to the 20th century and being able to identify so many. This century, I'm going to have to say, it's going to be the next great idea coming out of the mechanical engineering profession. So I don't know that I can give you a clever answer for the top invention that I've seen. I've shared some of them and I've got excited about them. To me, I'm just absolutely loving robotics. Robotics, 20th century approach, but we can now plug and play and we can really go fast. So to me, autonomous robotics or quasi-autonomous robots or human-in-the-loop robotics, that's exciting me. Long answer, probably not the answer you were hoping for.
Thanks, Peter. We have a question from Timothy Roman of University of Southampton Design Service and Experimental Officer. Thanks, Peter. You have shown a fascinating range of cases of success in innovation. We are inclined to be optimistic and wish for such a success. Failures in exploiting new technologies through small business are common and may take us by surprise. Are there common lessons from points of failure in the innovation process that really help your students and collaborators?
So quick answer will be, we now know a lot about scaling. And the UK is actually quite good at scaling. And so, scaling from your small idea or small business to massive success on $1 billion scale, or entrepreneurship within a big corporation and scaling those ideas so that your new idea becomes a dominant income earner for the corporation. So I think the lessons from scaling. I know we need to wrap up, so I'll stop there. Thank you ever so much for your questions, and Jan, thank you for hosting me in this Institution of Mechanical Engineers event.
All right, so we have a final question to wind up, Peter. We have a question from Yunus Bakhtiar Arafat, Universitas Indonesia student. In the next 10 years, will robotics be operated massively in all fields, especially in jobs that require high accuracy, speed, and effort?
To me, this technology is of age. So I think we will see large-scale deployment of robots in the domestic environment. So, domestic robots, a few robots in every home, perhaps. I also think that we will see them in regular use in society. But I think it will be divided. some will be very smart robots, some will be specific task robots. To me, the majority of them will be robots which can engage with us as humans. So, cobotics. Great question.
Thanks. Our audience is still so excited and still interested. I have a final question now from Chris Williams of Rolls-Royce. With the many disruptive technologies around today, do you have a view on the next Kodak or IBM that could be overtaken by early development technologies in the pipeline today?
Okay. So I've had the delight of engaging with lots of startups and also doing entrepreneurship with big corporations. And I think it's this audience that will be those agents of change. So back to my conclusion, there are just lots of opportunities. So whether it's going to be exploitation of classic technologies or doing nanochemistry or doing chemistry on the molecular scale and engineering it so that it works, so that we got batteries that are ever smaller with ever more energy storage to enable us our mobile world to be that much more mobile. So to me, this is just an exciting playground, and I am optimistic. I think you get that sense that whatever challenges we have in society today, engineering can actually be deployed effectively in the short term, I believe. So I'll just leave it there on that optimistic note.
Thanks, Peter. On behalf of IMechE Mechatronics, Informatics and Control Group, I thank all attendees. I thank presenter Professor Peter Charles for such a wonderful lecture to give us all inspiration, all the innovation, all creativity. Thank you. Thank you all for today's lecture.
Been a pleasure.
Thanks, Peter. Thank you all. I conclude the lecture today now.